It's a high-tech conversation
and a low-tech topic.
live on the World Wide Web via Zoom. Bench Talk 101.
Right, so welcome everybody to this week's edition of Bench Talk 101. This is our first guest speaker of 2021, and what a speaker we've got. It's very, very exciting. But just a recap, really, we've got a lot of new people on here tonight. So just to recap what we're all about, this Bench Talk 101 was set up so that we could all get together during the COVID lockdown way back last year in April, May time. And since then, we've had a lockdown in November, and now we've got another full-blown lockdown now. But what we found with this group is that we're all here to share our skills, to share our passion, share our knowledge and experiences all about woodworking and the tools that we enjoy to use. So it's very nice when we have a tool maker to come on and give us a talk like today. So those people that are new, I keep you muted all the way through till the speaker is finished. And then if you look at the bottom of your screen, you'll see a chat button. And all you need to do in there is write your name in the chat if you want to ask a question. And then we just do first come, first serve. And if Chester puts his name in first, I'll put him last. So because he's always in there first. He's there smiling away. What's great about this, though, is that we have been sharing our skills and our knowledge in sunny Bedfordshire, where I am at the moment in England, but actually it's spread right across the world. And tonight we can already hear people from South Africa, lots of people from the States. We've got people from Canada, we've got people from Brazil, Spain, Finland, and just to name a few there. There's many more. I mean, we've got Anton from Austria. We've got our regulars, Matthias from Belgium, but actually he's really from Sweden, but he's living in Belgium at the moment, and lots of other people. So we'll kind of park there. There's a few Scottish people as well online, which we'll hear more of them later on with their accents and when they're asking their questions. All in all, really quite a good shout, really, because it is bringing in the knowledge right the way across the world to share here on this Bench Talk. So less from me. I'm going to pass you over to Derek, who's going to talk, give you a quick intro for our speaker. So the best way to view this, everybody, is to put it into speaker view, and then you can see the person that's speaking up in their finest full up on the screen. And then when the speaker does come on, I will spotlight them. So hopefully that will give you a clearer picture as well. So thank you, everybody. And Derek, over to you.
Lovely. Yeah, thanks, Jeffrey. This evening, few would argue that a discussion about the world of precision engineering would be incomplete without mention of Joseph Bramah, Henry Maudslay, Joseph Whitworth, and Henry Royce. Pioneers in their own right, each of them pushed the boundaries of precision and accuracy to new heights with their skill, ingenuity, and determination to make unimaginable leaps in human endeavour by working to ever finer tolerances. Less celebrated but equally important are the small army of specialists practicing in niche areas of engineering that carry forward the principles of these innovators to make similar advances in the everyday objects they produce. A guest speaker on this week's Bench Talk 101 is every bit the maverick, a cabinet maker by trade, confessed obsessive perfectionist. He has taken the idea of a precision handplane to a standard unsurpassed by any other maker in his field. Now, I've had the pleasure of working with him on a few side projects over the years and always come away wiser from the experience and inspired to do better in my own work. I'm really hoping that a little of that magic rubs off on all of us this evening as we're joined by no one other than master plane maker Karl Holtey. So Karl, it's over to you. Thank you.
Well, evening everybody, and thank you for giving up your time for me. I suppose the best thing really is just get stuck straight into this and talk about something which I don't normally make, and that's a setting hammer. And the way that it really started, I've thought about it from time to time, and I thought, no, I can't really go there. And I actually made a plane which was a non-adjuster, a smoother. This chap I've got here, which is why I've labelled now as my 985. I think it's probably one of the plans I like quite a lot, and it probably might be reminiscent of the spear of ire, but I've tried to keep some of the bulk of it down. And the reason I didn't put an adjuster on it is because I wanted the plane to be as short as possible. Obviously it's a smoother plane, and when you're working on finished surfaces, they're not always going to be perfect. So you want the plane to obviously follow any contours and that. And so to get the plane short, I had to give up the adjuster. And I don't know whether it was a good thing or not, but here it is anyway, nevertheless. And I kept thinking about, should I make a hammer or not? And so I thought, well, okay, I'll give it a shot. And I spent several hours in front of a drawing board. I don't use a CAD or anything like that there. I don't think I've never put my mind to it, or my limited brain. And but that's the way everything I do really. And I spend a lot of time just drawing and drawing and thinking and laying awake at nights until eventually I start to get some idea on the direction where I want to go. And so really, I suppose the first thing you do is, if you think about a setting hammer, is that I want you to get away from the idea of just having a piece of brass on the end of a stick. And all the hammers that I've owned, not necessarily setting hammers, because I used to set my planes or anything I wanted to set without an adjuster, I would set it with a block of wood or something. And I don't mean there's a block of wood between that and a hammer, I'd hit it with a piece of wood. And so I designed a head and made it in a cylindrical form, and that was my starting point, which would be this little guy here. And I suppose really that as it starts to build, we might start to have some sort of a familiarity or a shape that some of us might begin to recognise. But it's a starting point, because A is that if I can find my little bits and pieces which have disappeared, here we go, we'd have a pad, and these would be turned and threaded in situ, and try to keep them a little bit tight. So you've really got to work them on there. And how long that would last, I don't know, because I don't really have that kind of experience, but they are available, and perhaps even, well, say a lot of people could probably make this kind of components.
Karl, if you hold it up to the camera so that we can.
How's that?
There we go. Yeah,
I've only got short arms. and there you go then. That's it. And that's why I don't do videos. You see, people keep asking me, saying, "Why don't you do videos?" And I thought, I just do stills. That's because I don't move around too fast. You see. So that was my starting point. And once I'd got there, because it's not easy actually, because you can start off with a round bar and you can cut it off and you can trim it off to dead length, and then you start turning down on the ends there to prepare a threading area, and that takes up quite a lot of time. And then you got this little fella in here, the hole, and that has to be absolutely dead center. And also it's sort of counterboard here, because when you actually connect a shaft or the neck of a shaft to it, it would fit in there just right, so it looks like it's joined then, and you'd see a minimal amount of joining area there.
You'll have to keep it held up, Karl, because we can't see the bits. It's we kind of know what you're talking about, but
I'll try and I'll get the hang of it in the end. But
yeah. Sorry.
Yeah, that's okay. But because I'm looking at, trouble is that my eyes are going to the real item and then the image item, and then I seem to let things slip. And as you can see that so you got this part here, which will then connect onto this chap. But that will come. I'll follow this one along in a minute. But when you're showing at the other end, I couldn't make it a blind hole, because then it would weaken it. So I'd have to show through the other side. And the reason that I wanted to make this as a metal shaft or screwed into the head is because on all the hammers that I've used over the years, is they always seem to work loose. especially my little peening hammer I use when I make me dovetails or etc. And it's so irritating because I've got hammers laying around, and when they start to work loose, I usually just keep working super glue into them to try to, sort of steady them up a bit, and then they still keep working loose, and it used to drive me crackers. So I've got this, and so when I produce this, that I had to think, where are we going from here now? Because I want to go into this metal shaft, and the thought that there's going to be an area or a connection area that between a handle, which the handle then would still have to be wood. And well, as you can see, you could see a sort of a transformation taking place. Is that if I can unite these two together, and now you can see that it goes together as quite a tidy joint there, and that's what I was looking for. And then when you look at the end, because it had to be threaded right through, that it had to look neat and tidy still. Let's pull that right back away. And so you've got a round object now which you're going to try to mill, and you have to work then both sides, because you've got finish on this side, and then I've got this finish on this side, and I'll take it back out again. And the way I've got by, I can't have everything with me because I'm just speaking for my house, but I've made 2 square blocks which had to be quite true, so that they would then screw onto the ends of here, and then I could set them up into a milling vise. And then once they're done up tight here, and then you're operating on stops, that all you have to do then is just rotate the stop, and then it's going to be perfectly lined up for the other side. So I'm able to have a perfect countersink on one side and a bore on the other side. It's probably not rocket science, but it's just the little small details to get everything to come out right and spot on at the end. And I've probably spent loads of time throwing things away until I tend to sort of achieve these little things. And so after many hours, and I cut myself a load of these until I got thoroughly bored, and I don't ever want to see any more again. And so now then we have this shaft. Incidentally, the shaft is quite a fine thread. It's an 8mm, and the thread pitch on it is 0.75. And I went for a fine thread because I wanted as much strength in there without wasting it down too much. So I just kind of arrived at that. It's probably stronger than needed, but I get that paranoia sets in. I'd hate to think if there was a failure anywhere. So here we go. I'll put him back on again, and we'll start building this thing back up together as I talk. And so that's the bit we're going to see that far. And then the next stage, before I get off the end there, you can see that there's all of this is cut out of a 12mm bar, this shaft. And I have to turn this down. This is also pre-bored. So then that is threaded part way in to take one of these chaps, which is this fella here. And you can see it's a hex. This can farm the lens. It's a hexagon part. And I'll explain the hexagon in a little while. But it seems to be very poor focusing, because I think the camera's trying to focus on me and probably not the object I'm holding up in front. So I have that. So that is a center section for the shaft. And this would then screw into here. Also, that where this rests up against the wooden sleeve, which seems a long way away at this stage in getting this far, I would need to have a ferrule. And the ferrule is just a ferrule, but to actually make one is a different story, because that's made from a solid bar. It's not pressed or anything. and you don't buy it for DIY shelf. And it's very time consuming. So you need to be well organized. And I find that to cut the counter boring section out of it there, that it was easy producing this all cut up neatly to length on a lathe. And then they'll go into a milling machine and mill the middle out, because it gives a nice flat area in the bottom inside, which if I can get that right, which you wouldn't do through drilling, and it's very difficult to maintain an exact size through trying to drill it or bore it on a lathe. But the mill does a better job, and it goes around with a smaller cutter and goes around in a circle, and then you get a nice flat finish in the bottom. So then we have that as the next stage on this handle. And obviously I think most of us will probably understand why a ferrule is necessary, because if you have one of these chaps here, incidentally, these are my favourite. Obviously, they took me the longest to make these things, and so that could fit on there. I won't push it down because I might not get it off, but that would give you a lot of protection there to stop any splitting or breaking around on the handle. You know, hence why that they almost you couldn't possibly make a chisel without one of these on there.
Karl, I've been asked by one of the members, giving me some advice. They said if you sit back a bit and don't hold the things up to the lens, then everybody would, yeah. So if you hold it back there, then it's still in focus and people can see what you're doing. Thank you.
Yeah, because I wasn't getting any focus. Okay. So so once I got this far, we're getting quite a long way advanced with a metal stem. Then the other thing is that I needed the handle, or in this case, it'd be a handle sleeve. And the thing that I arrived at after much deliberation was going to be boxwood. And boxwood was I also used for these pads, and I also used lignin vitine, but somehow the boxwood just seems to matter more. It's well, I can't explain boxwood, but I'm pretty sure that a lot of people would understand what I'm trying to say. Really, it's not the prettiest wood look in the world, but once you've handled it and you've worked with it and you've used it a lot, there's nothing that comes close to it. I just sort of love it to bits. And if you can get hold of a really nice piece of boxwood without any blemishes in it at all, absolutely clean and perfect, you have to cut an awful lot of wood to get there. So you get, it's quite a lot of wastage to get there. And I've got myself a number of these, but probably not enough to go around to all the plane shafts that I've made, and I'm still turning a few now until I can put this whole project to bed, because it's been driving me crackers for the last 6 months. So okay, then I'll move away from this now, because for the time being, because this has to be fixed. This can be tightened, and you can even put a thread locking on it, which could probably be recommended because of the vibration at this point here, could work it loose. And that was the main object, is that I didn't want a hammerhead that was going to work itself loose. And so if we pass it through the shaft here, that they've got no way, this one's tight, I'll find a better fitting one, or let's do it this way. That it should run through there quite easily. I've done this earlier on. They're all tight, but it means I've got to push them, and I don't want to push them because it might take a job getting them off thing. And that's another one what works earlier. When I push these through, is that I've got to be able to hold them, and so this is screwed tight to the head, and then now I want to hold this by compression. And this is the reason I've got this hexagon section in the middle, is that that's broached through the center of the handle, which makes it quite a challenge to do that. And I'm not really very good at explaining things, but I'll keep trying. This is a T-nut, which I made. And I wanted a T-nut to work at the other end of the shaft, so then that could compress the whole thing together. And the only other thing is now I've got everything here, which is all round, but I thought, well, I've got nowhere to leave my mark. So the only place to leave a mark was on the head of a T-nut. So I could have no driver there at all, no screwdriver slot, no holes, no nothing. That's any better. And I wanted that mark. And of course the mark is stamped, it's not engraved. I prefer the stamping principle, I suppose it's more traditional, but I think it gives it a little bit something else really than an engraving. And so I thought, well, I can't drive it without something. So what I had come up with then was to go back here and you can screw onto the end of this hexagon piece now, and you could probably put a little bit of a lighter strength locking compound on those threads so that the two will be united. Now you see we've got the driver now, because I can actually rotate a handle, and then I'm rotating this hexagon, so I've got my clamp now to pull the handle up tight. And that is the whole thing really. I suppose really it could be considered unique, because I don't think there's anything like this that's ever happened, or anybody else that's done anything like it. I know that people I've seen setting hammers which will be a cylindrical head with a thin metal rod in it or something, but there's no substitute for a nice wooden feel on a handle. The other thing is that I'm trying to lost my direction here. I have to try and watch my language here, but trying to I'm not very good at explaining things, but to try to get a handle is that how much am I going to be able to have of wood on a handle? I've got to consider the whole weight possibilities. I've got a stem which is made out of steel, and I'm trying to decide what the right balance or the feel of a hammer should be. And so again, after many hours on a drawing board and looking at things, I got the shape of the handle I wanted, and this all had to then be worked out to work together with a handle. I'd probably rather at this stage probably hold up one of these instead. And you can see what I've got is I've got a hammer which has quite a short handle on it, and it feels natural. If I've got a hammer for putting in nails and things like this, I'd want a longer handle on it naturally, because then I would probably, off this, I might have chopped off about that much off it. What some people would consider as a normal length hammer handle. And when you pick this up and you can see it laying down. I mean, if I put it down, you won't see it, but if you pick it up when it's laying down and you see it there, and you just want to naturally have an impulse, I think I want to pick that up. So when you pick it up and you just put your hand on it, it's there right where you're going to use it. You're not, you're going to pick it up there, and that's exactly where you want it. And when you actually hold it, it's a pity that I haven't got items like this to pass around for people to feel or touch, because it just feels right. And it's so rigid and it feels so nice. And you've got a little bit of weight going down here, but the balance doesn't feel bad or wrong at all or anything. And if anything, it probably enhances the head a bit, because when you strike or you want to bump any object with it, is that it gives you a little bit of extra energy. And for making very, very fine work, for just tapping the blade into position, it does, you actually get a good feedback for it. You know where you are with it. And I suppose it's come a long way for me just using blocks of wood. But it's right. And 6.5, very nearly 6.5 ounces. And similar products of this type of thing would be a bit lighter than that from the ones that I've seen, but it's very difficult to get the information because I think one or two don't even put down the weights or tell you what the weights are. It's all the little things that I'm going to say, and then they sort of go out like lights before I get there. But
you mentioned about how you made the wooden shaft, and you worked out how you did it on the the different tools that you used
on the metalwork.
No, on the woodwork.
The handle sleeve. Then.
Yeah.
Well, first of all, it's a project all on its own. It was the biggest job of all, and it was a nightmare. But like most jobs I do, they're all nightmares. Well, in different degrees, and I think I'll cross that bridge when I get there, and that's how all my work is that I never quite know where. I know where I'm going, but I don't know how. But it's a thing is that as you progress, that you get there, and then you have those little eureka moments, and then it's sorted. But it's usually the old price really, and that is just sheer graft or work. And so how I arrived here is that you have to cut these out in perfect square billets of right length. So I start off, I can go through planing with just a wood machine. That could be good enough as long as you finish up on a good planer and put it through a thicknesser so you can get them all out fairly consistent, nice and square. And then I work by the old-fashioned methods that woodworkers use and put a face edge and the face mark on it. And then you use those marks. So when it goes into a milling machine, because now you see, with that square, that's in a position now that I can do my milling. And I forgot to bring the squares with me because I had some started in a midway point and how you actually get here. And that is that I have to drill from both ends. Well, if it's in a CNC machine, then I have to make up a work holding fixture so it can stand in a vertical line, and it's got to stop, etc. So then I know that I'm set up, and everything that I do then is work to absolutely dead center to its axis. And so I can go down. There's two drilling sizes. One size is the size I need, which I'm going to form a brooch, and then the other side is a clearance. There'll be a clearance for this chap on the end here for the T-nut, and then on the other side here there'll be this one here, which is an 8mm or just over for the fore-end portion or the neck section, then, if you like. And you take advantage of, once you've got it in a milling machine, that all this work around here is not lathe work. That is actually done on the milling machine, so I can cut that circle there because I need that, because that's going to fit my holding fixture for the lathe. And the same here. I need that bore in there, even though that takes my T-nut, to fit the fixture in the lathe. So in other words, it's my mandrel, and the mandrel will go into I've got this square section, and I've got two round portions already started on the end here, and that will slide onto the mandrel, which then goes onto a lathe. In this case, I'll be using an engineer's center lathe. Got something stuck in my throat. It's just a little lubrication. And then I can run off the square portion here, because it's a lot of material to move. I can get buried or disappear under shavings just like that. And then I can start around, so I can be fairly close to actually turn the rest down by hand then at this stage. So I've made two mandrels. Both mandrels are identical. And I'll set the second mandrel up in an ordinary wood turning lathe, my little Wadkin lathe, which is my favourite. and then I'll make up a template to with a follower, so that the follower then would be the tool piece, held into the follower, and then I can go along and I can then produce the final contour. Again, using engineering tools for the cutting, etc., because they're nice and sharp. So using tungsten carbide, they stay sharp right from the one end, right from the very beginning, and stay sharp to the end. And I can produce that. Although that I find that if you're cutting woods in there, and I've never mastered the use of hand turning lathes, like woodworking lathes, because it's the right sort of pressure that you put onto a job, and I tend to bust into them a bit and rip them to pieces, so I can't control them very easily. But with the tool the tool holder that I made, and with a little follow guide onto it, I tend to sort of creep along it a bit, very gently, very carefully. So it takes me an awful long time. But that's how I got there. I used the same technique of making that handle as I did on another tool that I made, which was a purfling cutter. And again, incorporating using this hexagon thing here. And I forgot to mention is that after I finished putting my round ends onto this square block, then that had to go through to be broached, and then I have to push a broach through that as well. So then I've got the actual form then for the key for the hexagon. And it's I suppose you think there isn't much really to explain about a hammer, really. It's just a hammer, I suppose. But it's the only one like it.
And it looks good, Carl.
I could probably I think I've sort of more or less said as much as I can, because I'll always remember things I've forgotten to say. But I would like to leave that to you and anybody else in there would like to ask any more questions.
Oh, lovely, Carl. Thank you very much for your talk there. And probably what we should have done in the first instance is done a raise of glass, for a bench beverage to keep you well lubricated. So we'll do one now, and then we'll maybe do a few more as we go. So cheers, Carl. To the bench and to Carl. So we're going to have some questions now. So I'm going to let people unmute themselves and then ask the question. So the first one up, I'm going to go back to gallery view, and the first one up. Oh, there we go. Lord Captain Sir Major Purple Heart. And I need to allow him to unmute himself. So where is he? There he is.
You already have, Jeffrey.
There you go. Off you go.
Hi, Carl. Thank you very much for the brilliant talk. I just wanted to pick up on your when you were talking about the weight, where to balance the hammer and so on. Now, I'm not sure many of the bench talkers know I'm actually a professional drummer, but I don't play a drum kit. I play an Indian drum called a dol, a DH. It's spelled DHOL.
Using these?
Sorry?
Using your hands?
No, it uses two sticks.
Oh, sorry, yes.
Yeah, so I've got two sticks here.
Okay.
This would be used to play the treble side. This would be used to play the bass side. Now, something interesting with these is that you would get the balance point where your index finger would hold, the stick, because that gives you precision and control, and you can control it perfectly. Now, I was just wondering if that ever creeped into your thought process when you were determining how to balance the hammer.
Well, when I started doing this, is that I had to forget any ideas I had about a hammer altogether, because all I wanted to do is that I just wanted to move an object, not like most hammers are either used for some form of beating or for driving other things such as nails, etc. And I've worked many hours in my lifetime, in my earlier lifetime, I'm a joiner, but I've done lots of site work, etc. And I've used hammers above my head when you're working up the ceilings or out here and driving along great big objects until my arms are nearly dropping off. And I would hold the hammer at its extremity virtually to get and with a full force of your arm to get the maximum energy from it. But this is completely different. I mean, you get different styles of hammers, whether you've got a pin hammer, or you've got the most popular hammer, I think, for any bench worker, woodworking bench worker, would be a Warrington hammer. But one of my favourite hammers, I suppose, when I was on the bench. But this had to be thought out from afresh, because you see, it's not just a plain setting hammer. I just call it a setting hammer because a machinist would find a good use for a hammer like this. Anybody in any other little trades, jewelers, anybody that works with tools, and probably on probably a bench environment, because it's a bit too pretty to have somewhere else. But it's handy. But when you actually hold it, the weight there, in one sense, wherever the balance is almost irrelevant, because it's not going to be an instrument. It's just an object. I wanted a nice parallel head balanced at both ends. Not because I wanted a double-ended hammer or anything, but it was just a balance. Because
so where is the balancing point, out of interest? On that?
There's no balancing point on that. They'll probably be quite far forward, actually.
I guess because it's
out there somewhere. It'll drop it when they go, but it's about
would
there.
make sense with the steel head. So
yeah. So really, part of this is effective almost. You know, from when it comes to the energy coming through here. But that would probably be there was about the nearest point I can get it to without it falling. And so it's basically everything is there where I want it. But you see, if I'm going to be setting something like as fine as a plain blade, then obviously I want a very delicate control on it. But I find it's easier to have the necessary feedback and control on something of this size and this weight and shape than it is of a finer object. And also, I didn't want a brass end on anywhere or anything like that, because I couldn't see the point of actually wanting to hit something with metal in it. And the other thing about the brass is that the brass would start to swage after a while, and it would spoil. Well, this will probably get a few nicks and marks on it, but the brass does swage. If it had excessive use, it would probably disfigure quite easily. And but I thought it was unnecessary, because you can hit anything with that. You can hit metal with it if you want, and you can hit well, of course you can hit metal with it, but you can probably hit the back of a wooden plane to see, you know, to persuade the blade to lead backwards. So you can get a good clout with it as well as a very fine controlled one. You can get a good stiff whack with it, and you wouldn't have to take a long swing at it. You could do it with a reasonably short swing still. And I think that's the whole key of it. Really, it is a very short swing. So it's a short hammer, and the hack. I mean, when I've worked with hammers in the past, or, you know, doing all sorts of jobs, I probably might be guilty of even holding the hammer by the neck in the first place, probably, but because it depends on the kind of work that you were doing. But this was only just, it is what it is, I suppose, really. And I think I might have, in my own mind at least, is that I've come sort of fairly close to what I thought would be working right for that kind of condition.
Lovely. Jim Hendricks up next.
Hi, Carl. Thanks very much. That was fascinating, and it's beautiful to see somebody actually go into that depth in looking at every single nuance of the engineering. It's very few people these days actually go to that amount of detail. One question I have, which is a technical question on the engineering side, when you on the boxwood sleeve make the hexagonal core, you presumably you cut the inner diameter and then broach it through. Do you use just a standard single broach and then slowly push it down, or do you use any machine broaching?
Well, I'm sorry that I didn't bring more with me, because I could have probably had more items to show. But the broach itself would be, in this case, it's the smallest measurement there, from flat side to flat side of the power, so this one's 1/4 inch. Am I holding that near enough about right? It's 1/4 of an inch, and it probably to its extremity somewhere like that, there might be about 5/16 of an inch, but so obviously a 1/4 of an inch pilot hole then is required. And the broach would be about, well, the actual cutting portion of the broach would be about that long. So and there's lots of little cutting circles around it. So it would, they would graduate as it comes nearer to the end there to get the full form. So
so it's a static brooch then. It's not any machine broaching tool at all. It's just a standard brooch. Yeah. That's all I was, because you're really only taking a very fine amount of material off.
True too, you know, and you've got to have a machine to do it.
Yeah, absolutely. No, it's one of the things that I do struggle with sometimes, because I do square holes, and then because with the hex you're dealing with moving less extra waste. Once you've done the pilot hole, you're only taking a tiny bit out of the 6 corners, whereas with the square you're taking 4 larger pieces out, aren't you, effectively? And
I use a square brooch, and the thing is, with the hexagon brooch, you can end up with the full perfect form. Yeah. But I've noticed that with the square brooches, you still leave a little bit of a circle behind in it. That's how I'm using a commercial brooch.
Yeah. When I had to make a square hole, when I made the Holt's at full gauge copy, I ended up. That's the reason I asked, because I'm looking at a better ways of actually making a round hole into a square peg sort of thing. There are machine broaches that you can get now, those wobbly things that wobble and somehow magically cut a square hole from a circular pilot hole. But I ended up making a brooch.
I've heard about these, but I've never seen one in action.
No, I don't know how they work. They just go round and they end up cutting a square, and I just don't know how they do it. But it's
corner.
Say again?
It goes into a sharp corner.
I think it hits a corner and creates a corner and then stops it. And someone, I don't know. I've watched one working, but I've not. But they're absolutely ridiculously expensive. And I thought for one single job, I actually prefer to cut near to the size and then just file it out, which is what I ended up doing anyway. But no, I was interested because so you used a commercial machine, just a fixed brooch that punch down into the pilot hole and cut out your hex. Yeah.
Mm-hmm.
Yeah, perfect. That's all I need to know. Thanks for that, Karl.
Oh, you're welcome.
Lovely, thank you, Jim. Derek, over to you.
Yeah, thank you, Jeffrey. Okay, I want to speak a little bit more about the brooches, because I was interested when you were talking about that. I'm not familiar with the concept of a brooch, but from what you and Jim have just spoken about, do I understand that the brooch is a cutting tool, not necessarily the sort of clearing? Is clearing waste somehow, is it, or sort of cutting? And where does the waste material go?
You would start with the smallest dimension, which will be round. Mm-hmm. And it will be a rod, which, for want of a better description, with lots of circles on it, which will gradually work up from round to full form. So as each section passes through, it cuts a little bit more, and then a little bit more, and a little bit more, till you get to the end of the brooch, and then you have your full form. Okay. So effectively, you're sort of forcing a tool down that hole to create a hexagonal shape. So your shaft from your hammer is actually locked into a length of hex section, that sort of size, or that sort of length, is it? Yes, the actual cutting tool itself is about that length. Mm-hmm. What I do for what I want is that I might have a long reach into into this shaft here, or the sleeve, but there's only the actual. Well, you can see by the length of this that there's only a limited amount of engagement through a key anyway, I would push from this end here because it's the longest reach, but I want it to stand on a bigger, flatter area, because don't forget, as I explained a little while ago, if you was to go onto my my Instagrams, and I think I've got a picture. No, it's on my website. I've got some pictures of these square sections with the ends sort of pre-worked on the mill ready to go on the mandrel. Well, it goes from the mill to the broaching machine, and then goes on to the mandrel into lathe work. So if I'm broaching this way and that sits over it on the, you're not putting on the bench here. If that sits onto my bench, I can't see myself. I'm looking in the wrong place.
Okay.
It's my bench that I can then put the broach tool in there, but I've made an extension on the broach tool, which is just a little dowel fit on the ends, so that it gives it a little bit of extension, because I've got to push the broach right through it until it falls out the back.
Got it. It's like a hollow chisel then, isn't it, really, effectively?
Yeah.
Is that how it works, like a hollow chisel?
Like a hollow mortiser?
Yeah, but it doesn't, well, yes, it does really, because it's still cutting, yeah.
Yeah.
It's actually tapered. So the bit at the top, let's say it's for make it simpler, Carl. If you say a square one, the bottom bit is a small square, then there's a bigger square, then there's a bigger square. Derek, you know those things that you drill multiple holes, it comes from China, and you start with a little one, horrible things,
I know.
and it gets down and down and cuts. Yeah, it's like that, but it's not rotating, it's pushing down, so it nibble. It's kind of going down like that, and it's because it's tapered. As Carl said, it follows the center pilot bore.
Got it.
And as it's going, it cuts a bigger and bigger and bigger and bigger hex till it gets to the dimension of hex that you want for the hex bar that locks into place.
Fantastic. Lovely.
Another better way is that's another method that they use for cutting keyways and gears and things like that. You know, a keyway that drives it on the shaft with the shaft engagement, and you have that single keyway that you put in. You know, if you've got a gear and you want to put it off, and you knock the key out or something like that, then and pull your gear piece off.
Got it.
Yep.
Lovely. Thank you, Carl.
Chester, over to you.
Yes. Hello, Carl.
Hello there.
Thank you for a great thing that you did.
Well, you're very kind. I'm not very good at it.
I think you were fine. And no need to be nervous. That's a beautiful hammer, and I think it's a terrific project. My questions for you, really, I just started to occur to me and I love boxwood. It's one of my favorite woods since I've gotten some from Hugh over there.
I love it myself.
Yeah, but I wondered, you did both ends the same, and a lot of those type of hammers will have either a lucite side and another side that's different, either a different material or a different side that's a different shape. And I wondered if you gave any consideration to changing one of the ends to be more like a joiner's.
Well, that's what I call the Warrington hammer.
The Warrington, yes, absolutely. And I think you could still do it with boxwood. You would just, chamfer two sides. But I wonder if you thought about that at all, because I just noticed that both ends were the same.
Well, because this is basically, it really resembles a gavel, doesn't it?
It does.
Yeah. And in a way, it probably feels like a gavel. You can use it as a gavel if you want.
Sure.
Another marketplace.
Yeah.
But,
I was just thinking that you could even do some sort of a way to access a wedge this way, as well as doing the, adjusting the iron, but that you could use a different shape to get into a tight corner. But what you've got there is absolutely beautiful.
But when you're fixed on by threading, you can't be sure where you're going to stop it. But you can still hit your wedge from there. But it would be nice. It'd be nice to say what you can say. And first of all, I was thinking, that would be good. But because of the way that it's fixed, I can't be sure where it's going to stop.
Yeah, you'd almost have to do it to each individual one after it's already affixed to it.
And if you lock your threads.
Yeah, but it's a lovely tool, and thank you so much for sharing it with us.
Thank you.
Really, very, very nice. Great workmanship.
Lovely. Richard Hughes, are you ready to give your question?
Yes, you're unmuted now. Good evening, Carl. I was just curious about what screw threads you're using. Are they metric course, or are they some other threads?
The screws, right? The only screws obviously is metalwork. So here, where it screws into the head, is a very fine metric 8mm, which is a 0.75 thread pitch, and I chose that because I was limited on the diameter of that contact, so I went for the fine thread to keep as much strength on the nose of it that I could, without having to bite too deeply into it with a coarser thread. Does that explain?
Yeah. Okay. Yeah. Thanks. Yeah. And the other thread.
The other threads is just quite standard, but obviously all metric. That's an 8mm by 75. The can't remember what I've done now. This one here is also 8mm, but it's by 1.25.
Yeah, that's ordinary metric course, isn't it? Yeah.
Yeah. Because I take it you're American. Oh dear. Sorry.
Richard, this is a perfect opportunity for you to show off the Yorkshire hammer, isn't it?
Yeah. Well, it shouldn't really be seen in the same sort of arena as the Karlsruhe hammer. I'll go and fetch it when someone else is speaking. It's down
below right now, because
I'll bring and show you.
I've got a very good sound system on this, you know.
It's the Yorkshire pattern plane adjustment hammer.
I could have called you a Leicestershire man.
Well, Lancashire, Liverpool originally, yeah.
Oh, really? So, but you obviously you're confusing then. This one here is a 6x1.
Yeah.
And being a Brit, then that you'd be familiar that we've had rectification thrust upon us.
Yes, indeed, yes. But I use British threads whenever possible. Probably because I inherited a good set of British taps and dies, so I just stick with them. Where
are you a Whitworth person then? Or?
Yeah, well, Whitworth, BSF, gas thread, BAs, you name it. Yeah.
The proper threads.
Yeah.
And it was Whitworth that invented the standard in the first place.
It was, yeah.
Yeah, so it's yeah, I do, but I in the end I've had to knuckle down and work with metric because it's hard work trying to stay imperial.
Yes, yeah, and yeah, I guess your machine tools are metric, are they?
Mainly buying things like cutters and whatever, because you're just not getting the choice anymore, and I spend a fortune on cutters. I don't use. I very, very rarely use high-speed steel because everything I do are the very, very best grade carbide tools, and usually coated that I can get my hands on.
Yeah.
And so that to some people it could be silly money, but in my case it's not. And what's more, when something goes past its best, then I have to throw it away.
Okay.
I used to take things out of their boxes and then put them back in their boxes. And when I take them out, once it's been used, I'll mark the box and say used straight away, and it goes back in the drawer with all the others. I've probably got serious money in drawers and drawers and drawers full of cutters, and I do have a lot of stock that's not even been used, because if I'm doing a really, really special job, I'll only put in a brand new tool every time.
Yeah.
And then the ones that have been used, and I sort of run over a grading system, and I'll run them down, but they go out the door very fast. So once they get to that stage.
Yeah. Okay. Thank you very much.
Thank you for asking the questions.
Yeah, I'll go and fetch the Yorkshire hammer.
Yeah, I think you ought to. That's going to be very good to see. I've got a couple hammers back here that, like you were saying. Well, I'll put it on a spotlight so that you can see it, Carl. But this is when you talk about the brass on the end, it soon ends up marking like that.
Yeah, but the brass is very convenient for a lot of people because it's the parent material, then, isn't it? and then as the extra item, then you put in whatever you want as a softer contact.
So this one here is Ollie Sparks' hammer, and it's actually it's really quite nice to use. Actually, it's got the handle shaped so that you've got the bit of edge on it.
Yeah, well, I've sort of clocked the fact too is that the handle gets bigger towards the end.
Yeah, and the same with this one where the handle gets bigger towards the end. This is one from Brian Sugar down in Australia. You've got an ebony on one side, and it's I've just lost the name of this wood. It'll come to me in a minute, but it's got a bit of fancy. No, it's not the Gidgee. It's it'll come to me in a minute. And you've got a bit of mockhume as the metal there. So I don't know if you've seen the mockhume before, Carl.
With the patterns in it.
Yeah, so it's a three. It's like Damascus, but it's
but quite expensive. There's a lot of work in it.
A hell of a lot of work in it. Yeah.
Oh yes, nice. That's very nice. Yes, it is nice. I've sometimes thought about that in some of my planes using those sort of exotic materials.
Well, yeah, you've got one here which is a smoother. Everybody laughs at me with my fingerprints, so that they go on there. So there's a smoother there. So that the ring is on the top there.
Yeah. How long can you hold that pattern for? Because you've got to rely on a chemical to keep the pattern up there, haven't you?
Oh no! It's the opposite actually. This one, what happens here is that the pattern gets more and more stronger as the materials
oxidation process.
Oxidation, yeah. So when you first get this, it's very light in color, and you can't really. The pattern's very, very, not very strong at all. And the older it gets, the darker the materials come, and then the lighter, So if you look at the nickel that's in there, that stays silver, and then the copper and everything gets darker and darker.
So it's not a Damascus then; it's that mockhume.
It's mockhume, yeah. This is mockhume, yeah. So it's but and then you've got like an interesting take on a Japanese kana, so a pull plane.
Yeah.
By the same. So that's there. So we've got some more questions coming up now. Take me off of spotlight. I just thought I'd show you some of those bits. Oh, there we are. Richard's back. Richard, have you got your Yorkshire pattern?
Okay, so this is your Yorkshire pattern plane adjustment hammer.
Okay.
As you can see, it's made on a Yorkshire Imperial Metals 15mm plumbing T-piece.
So I think if you hold yours up at the same, Carl, I've put you both on spotlights. I think
yeah, because I've where am I now? Okay,
similar here between these two, isn't there?
Yeah, but mine is female and yours is male.
Oh boy.
Put your hammer up though.
But that's more reminiscent of a gavel, really, isn't it? Those two rings.
Yeah. Anyway,
reminiscent of a leaky pipe.
Oh, that's a joint.
Yeah, it's a T-joint.
It's a joint.
Pipe.
You're not gaining any weight in the middle area.
I added some weight in there.
What, lead? Something?
Yeah, really steel. In fact, I drilled into the end of the wooden handle and put a slug of steel in there. And the brass goes quite a way in, but it's obviously it's rather lighter on the wooden side.
Oh, that's ingenious.
Yeah, so it's not my idea. I got the idea from an Australian called Tony Jarros who proposed it as a sort of joke. So I thought I'll make one and see if it works or not. And well, it does work. It's not pretty, but it's actually quite a convenient little hammer.
Well, I would imagine if that was polished, it would look quite nice. Well, I say because it's dull at the moment, but I mean the copper is very, very shiny anyway. I've got some of these made in brass, and the only thing is that I don't know whether I'll use them or not, because I thought they were for what I do and for my part that this I can hold this. I haven't got brass one with me now, but they can hold them together. And I'm just thinking, first of all, I thought brass is the one, and then I just got into this stainless steel, and that's where I stayed. I don't know what other people think, but I bounced my ideas off Claire, my wife, quite a few times, and I sometimes I even listen and take her seriously.
Hope she's not watching this one.
No, she's in there.
So I've got one more question for you, Karl. You know, you think about all the planes that you've made over the years. Which was your most favourite to make? You know, which one did you enjoy the most?
I never enjoy making any plane because there's so much bloody hard work. But it's the satisfaction you get at the end. But the actual making of them can be very stressful.
Well, okay, then let's reword the question. Which is the most satisfying plane that you've done then?
How's that one?
Oh yes, yes.
That's beauty.
I was very brave with this one, I reckon. I was really brave because I'm thinking, what am I going to do here? What am I going to do?
What is the job made of?
I didn't want a conventional wedge or anything on it. It had to be right, and I just took a total punt at it and just like, just do it. I hadn't got the luxury of making prototypes and trying things out because even prototypes can take so long, and I have to make things and get it right first time.
Is that a lateral adjustment underneath the palm piece?
I'll take it apart in front of you. See, that's the lever cap now, which has obviously got a retainer here, so that is locks onto the bridge. And this here, this little fella here, I might not get the handle off because it'll be so tight that it'll be almost impossible unless I get it properly secured with some kind of a wrench to get that off. But that is the handle. But the whole thing is that there's a bush and a spindle combined, which is cemented into the handle, and you would never ever get that handle off. It would. I can screw the handle off the lever cap, but you'd never get the bush out of the handle. It's there for good, unless you want to break it out or cut it out. And then I got this guy here, and that's sort of, see, everything I do about it is work, work, work. Even this this is in actual fact, it's a swivel that will move, so it'll always be flat. When any pressure on that, will always be flat to match the plane of the blade that you're clamping.
So that way, when you tighten that down, you're not pushing the blade forward at all or sideways.
No, it always
just stays.
Yes, you're right.
Really.
And it's you know, it's just that you're looking at the whole thing, and there's a lot of contour changes and all sorts of things going on, and you've got to plan the whole making and the manufacture of it out. And it's very, very fine process to get there in the end. And but I made one batch. I can't remember how many was in the first batch, and I made one batch, and I was going to keep one back for myself. And a guy from Finland was going to come over here to go to a funeral of a mutual friend of ours, and which I didn't go to, but he asked if he could call in on me while he was here in the UK. I mean, and the funeral was in Edinburgh, and so he come quite a long way out of his way to come here anyway. But when he saw this plane, and it was the only one left, and it was my own personal plane, and I could see the look of pain on his face that he wanted it, and I was thinking that the money would be handy, so we you know, I let it go, and that was that. But the only reason I let it go is because I convinced myself is that I'll do another little batch. And this was the second batch. And again, this is the very last plane. And that's it. I'm not doing it. I'm not going there anymore now. They're just.
But you're seeing that same pained look.
Making these things. They take a piece out of your life every time you make them. You know, I might be very expensive in what I do, but it's a piece of my life. I put so much effort into it, and I'm not rich, I can assure you.
Well, I mean, you know, you think about the work that goes into it, and you talk about the detail. I mean, you know, it's all in the detail that makes the difference. But you did make a series of miniature planes. What made you make miniature planes?
Sorry, I'm not understanding that question again.
Well, what made you make a series of miniature planes?
Oh, those. All right. I was at a David Stanley sale one day, and there was a guy that showed up with these. They were 1/3 scale, which I did, was a 1/3 scale, and they were nice work, but they didn't have adjusters. And I thought, did he back out small out of that by not putting adjusters in it? So I thought, it's a vanity thing. That's all I did it for, just vanity. So I did it, and that's it.
Well, they're absolutely quite.
Have you got one?
They're quite amazing, aren't they?
You got one?
Yeah.
I thought you would. Yeah.
So,
People thought that they would scale down. You know, I mean, they thought the prices would scale down. That's the one thing you can't scale down.
I would imagine it's as hard to make that than what it is the original. I mean, you know, I'll try and, for the benefit of those people that have not kind of seen this, but you know, when you look inside,
Oh yeah, Jeffrey, that's it.
Yeah, sorry, I sympathise. I know exactly how Carl's feeling now, and I take the blade out here. But you know, there is the there is the adjuster that Karl was just talking about, and it's just phenomenal. You know, when you see the dovetails and everything that's gone into it, you see, you know, well, look at the size of my fingers up against it. It's
although that plane is miniature. Oh, I'm just thinking, have I got one here? I've got one here as well, a full size one.
Yeah.
Yeah, there we go. And that I've got 2 of these left. I've got one. Yeah. Oh, was that a Del Berger?
Yeah. That's what we were on about earlier. That conversation.
Yeah. All right, you smart ass. You got them both. It's good when you put them side by side, isn't it?
Well, there's a great video because Derek has got one of yours, and we were, I don't know where we were, but we were mucking around and we got these out and we made a video of them next to each other, and I think it's on both Derek and my Instagram. So if you wanted to see them, and you've got them on your Instagram as well together, haven't you? So you can see the difference. So there we go. There's two more questions.
This is one of the very nicest planes, incidentally, I think there is to use, because it doesn't look ergonomic, but when you hold it like that, it feels right.
It's comfortable, isn't it? It's very comfortable.
No, you wouldn't think so, but it is.
Yeah. Right, let's take me off of this. So Shrenik wants to ask one more, and then we've got Richard, and then that's our last 2 questions for you, Karl.
Okay.
So Jeffrey already got onto the plane making. I was actually quite surprised that no one else had a question on plane making, and I thought I'd leave it till afterwards anyway. So I really want to make an infill plane, and it's because the process of making them just completely, to me, infill planes look like a piece of art as well as a perfect working plane. But I've never attempted it. I haven't started it yet, but I'm still sort of planning and making sure I know what I'm doing before I start. My question to you is, as someone who's not made one before, where would you recommend someone starts?
Sorry, that last part of the question.
So where, as a beginner, in terms of making infill planes, where would you recommend that I start?
Well, probably on the drawing board to make sure everything fits and goes together.
Okay.
Draw and draw it out on the board yourself, so that you know exactly where you're going with it, and then stick to it.
Okay. And what materials would you suggest I use, and what thick? So say I'm making a smoother, the size of a Stanley No. 4 or something. and I don't expect to use any adjustment mechanisms. Just a hammer and a wedge is what I expect to use. What would you recommend in terms of thicknesses of material? And what materials?
Well, you're talking about a smoothing plane to start with.
Yeah, so I'm thinking brass and steel, and what thicknesses of each? So brass on the sides and steel for the sole.
Well, because I've been through there and I've done this all, I've moved away from those sort of things because I got onto stainless steel because it's you've got an archival property to it, and it's not going to spoil over the years. And I've got this guy here. Look, if you can see here, it's starting to piss on the bottom. It's not been used, but I can see that all right. There's pits on the bottom. I mean, I can rub that out with an abrasive paper, but that is an ongoing thing with ordinary mild steel. But fine, if you want to, there's no point in using brass if you're going to use a stainless steel. You know, you might, because brass oxidizes badly anyway, and you know, that will just go brown as chocolate. But it's a good starting. I don't like to sound. I'm trying to sort of pour cold water over it, but I don't mean that. First of all, I would say that stainless steel is not as hard as you would imagine. It's very workable still. But if it's something that you want brass because you like the brass, or
it was more partly because they're easier materials to work with, bearing in mind that I don't have any machines to work.
But it's still a metal, whatever it is. You know, if you're working with a metal, there isn't a great deal of difference from switching from mild steel to stainless steel. Yes, stainless steel is harder, but if you can work mild steel, then you can work stainless steel. I think that probably the main thing really is for your very first project, I wouldn't be too concerned about the material that you're going to use, and for gaining that experience. Then, if you want did you want to use a bimetal situation of steel and brass?
Yeah, that's what I was planning.
Then why not? So what you intend to dovetail, so you want to that effect?
Yes, yeah, I will be dovetailing. Yeah.
So go ahead and do it. Even because, make the first project as small as small, you know, small by the fact that you get through that process a little bit quicker. And it's always the small planes that I think that are more precious than anything else. I put a lot of store into some of my small stuff, and it's a plane that you know, that assuming that everything goes nicely for you, that'll be very special to you.
Thank you.
Good.
Does that help you?
Yeah, that does.
I've not missed it. I
think I need to stop worrying about too many things and just get going and just do it, and then after that worry about how I improve rather than trying to improve before I start.
If you can draw it out on a board, you know, just a little line drawing or something like that, so it gives you your setting out, because the setting out is so important that if you've got your setting out, then you've got your map, you know exactly where you're going.
I'll do that. Thank you very much.
You're welcome.
Good.
Trinik.
Yes.
Trinik, I've probably got a PDF of the articles that I did with Karl many years ago in F&C magazine, which is one of the first things I worked on with Karl. He tried to explain over the phone to me about peening dovetails in metal, and it took several hours drawn out over several phone calls until the penny dropped. And eventually we put together, I think it was plane making over about 3, maybe 4 separate articles, of which I've got copies of those in a PDF form. So I will be happy to pass them on to you, because it breaks down the whole process of making, I think it was a number 10 plane, wasn't it, Karl? Putting a small number 10 plane together, infill, dovetails, everything. And I'm still allowed to share those if I want to. So that's yours if it would be helpful.
There's no adjuster on that one, was there, Derek?
No adjuster. No, really simple.
Well,
I've never
that's
made one myself. So
ideal project.
ideal first project, and I think that was what Carl was trying to talk me into, but I haven't taken him up on his offer yet. Maybe one day, maybe when I retire.
If you could email that to me, Derek.
Hmm?
If you could email that to me, please. Thank you.
There's a number 10 there.
I think that, was it number 10 that we did?
Yes. Yeah.
Right. Okay.
And
You don't have to snack the iron. If you want to make your own plain iron, you don't have to snack it.
There you are.
The snack, not the nib.
Yeah.
This is, I mean, that was a great collaboration because you worked with a bit of David Barron with this one, didn't you?
Yes. Yeah.
And this was David's plane, David Barron's plane.
You bought it off him.
Yeah, yeah. So there's that one. Right. So Richard Hughes, over to you. Last question, then we'd say our.
Okay. Well, it's two questions, but the first one is very quick, and that is, what grade of stainless steel do you use, Carl?
Well, I use the what I currently use wherever possible is the Martin Sittick ones, which are the 400 grades. And the only reason for using those is that I can stick them onto a magnetic chuck because they're magnetic.
Okay, yeah, interesting.
They're difficult to get. And that would be the best one of all would be the 416. But it's very expensive. You can buy it in the UK easily enough if it's round bar form. But if you wanted the flat form, that there are various people, mainly in the aeronautics industry or suppliers, that import it from the States. And because I think it is an American product, the 416, but it's probably about one of the best for this purpose because it's quite easy to machine and work. But other than that, if it wasn't for the fact that I wanted it as a magnetic material, I would go with the 300 grades. And that can either be 304, 305, or 316. And I always get confused between the 304 and the 305 because one of them is much better for machining, which I believe to be the, I might be wrong now whether it's 303 and 304 or 304 and 305. I think it's 303 and 304. But one of those is the higher number of the two, which I think is the better one for machining, much nicer and friendlier. But the 416 machines very nicely, but it is very much more expensive.
Yeah.
But the 300 grades have a much better rust resistance. So some of the 400 grades, especially like the 416, a lot of the gun makers use it for their barrels and things like this because it's there are lots of worthwhile properties in it. But I don't know too much, but I know for as much as I need for for my purposes.
Yeah. Okay. Thanks. Yeah. My final question is, you've taken plane making into new and exciting directions in terms of design and materials used, and I just wonder what you've got up your sleeve for the future, or have you got any new
Well. Yeah.
anything new coming along?
I've been getting inquiries or whatever. Getting more and more inquiries for these, and I'm not going there anymore. That's it. I'm not going there. But it's a shame because I like this plane very much. I also like this fella here.
I thought you were supposed to have retired, Carl.
I know. Well, I have. There you are. Because I'm not. What I'm doing is it's a hobby which I make a few bob out of it.
Was that the 98 you just said?
I just do what I feel like, and I sell a few. I slow down, and so going back to this question is that it's a good question because I've committed into doing another run of shoulder planes, and I would like to redesign a shoulder plane completely so I can make it back to a 9/8 series, but I can't come up with a design in my head to qualify that. So I might revisit my Spears pattern shoulder plane, make it all in stainless steel, probably using one of the 300 grades, because I have no need to actually clamp it onto a magnetic chuck. And I probably might make the filling from a synthetic material, because the wood is a bastard. It's constantly moving. You can't do any, what I call any serious engineering to it, because it just blows you away every time. So using something like a pretty acrylic like this, or even other patterns, it's safe. And it's not a cheap get out or anything. It's very expensive, and it's very difficult. It's easy to work if I'm cutting it, milling it, and doing other pieces. But if you're hand turning, it's very difficult, because it'll pull your cutter tooling in it, and it'll smash just like a piece of glass. But that's what I want to do. But the real thing I want to do is I'm 72 years old now, and I would like to think I could work for another 10 years. But in fact, really making another run of shoulder planes is going to be a bit of an annoyance to me, because I've got my eyes on the project after that. And that one will, I'm not too sure if I've got the model number right or not, but if you know anything about the history of Stanley tools, that it was, what's the man's name now?
Leonard Bailey?
I think it might have been it was a low angle smoother. Well, it wasn't really, I think it was intended as a butcher block plane. And I think it was a model number 64 or 60 something.
62, which is a low angle jack plane.
Yes, but it was small. It was only about 9.5 inches long.
Yeah, where's Chester gone? There was a low angle smoother.
I think it's that 164.
Yeah,
164, I suspect.
164.
Lee Nielsen.
Lee Nielsen copied it. Yeah.
Yeah. I like to read. That was my idea to do years and years ago. But obviously, I would do it in my style. But I would like to take that idea, because the beauty of it is that you've got an adjustment system that goes through the lever cap, and that gives you lots of room around the handle. You've got a low angle plane, but you've got lots of room around the handle because there's no adjuster there.
So you would use an adjuster different than the adjustment system you've used in the past, Karl?
It is very different, because it's still a Bailey adjuster.
Mm-hmm. But it's
But
overhead.
it's in a different form. It works at a different angle.
Mm-hmm.
It's annoying me now, because I can't think. Shade was the name of the man. His surname is Shade. I can't remember the first name now. And you find him in the book.
SCHADE.
Yeah.
That's who you're talking about.
I can't remember the spelling on it now.
It was SCHADE.
Shade.
Yes.
Shade.
Yes. Very good engineer.
Yeah.
And that was his baby.
And you're going to do it your way, and that's what we can say my way. And on that note, Karl, I'd like everybody to raise their bench beverages.
Thank you very much. I'll join you.
And we'll have a toast to Karl and to the bench. Karl and the bench.
Yeah, well done, Karl.
It's a high-tech conversation.
On the low-tech topic.
Live on the World Wide Web via Zoom. Bench Talk 101.